Hello everyone, my name is Samir Kumar Singh. Today we will discuss week 9 tutorial and question number 1 is on your screen. Please try this. First time reading this question. Question is consider a system with one transmit antenna and L receive antenna. Independent noise distribution as we will have a zero mean variance and not corrupt the signal at each of the receive antenna. The signal has a transmit power constant of P and suppose the channel is constant equal to 1. If the L received signal are added to obtain composite signal, so what is the normalized capacity of the channel? In this question, we have to calculate the normalized capacity. We have the L received signal. So please try this. We have one transmit antenna and L receive antenna. So we have to calculate the normalized capacity. Okay. According to the question, the scenario is we have one transmit antenna and the L receive antenna. Okay, and that is the noise. We have to calculate the normalized capacity. So this is the solution of this question. Okay, but basically we have the receive signal kth receive antenna. Suppose on the kth antenna we are receiving this. So yk is equal to x plus nk. Nk is the noise, x is the symbol. Okay, so but we have the L antennas. Okay, so for the L antennas we will add all the components. So suppose it will look like that. Okay, so this when you try to simplify this, then this equation will become Lx plus sigma k is going from the 1 to n and k. Okay, and this k is the noise, x is the transmitted symbol, and it's become L times. Okay, so from this equations you can conclude that this look like a single AWN channel will transmit signal power L square P and noise variance and not L and not. Okay, so the capacity of the signal basically we know that we log to 1 plus SNR to just put the signal power and the noise power. So our signal power is the L square P and noise power is L and not. So when we will L square will cut by this L, so it will become log to 1 plus LP upon N naught. So option B is the right answer. Okay, now second question is the statement type question. Okay, question in the second question is frequency hopping spread spectrum has a considerably wider bandwidth. Is this true or not? You just have to tell that when you apply the spread spectrum techniques, the frequency hopping is considered as a wider bandwidth or not. Try to solve this. Okay, so this is the false. Okay, because you already know that the direct sequences has a wider bandwidth. So comparatively, this is used in the CDMA. So frequency hopping is so this statement is a false. Okay, now question number 3 is the channel inversion doesn't require CSI at a transmitter. Okay, just you can comment your answer. Question is channel inversion doesn't require CSI at transmitter. Is true or false? Okay, this false is also false. Basically, explanation of this question, channel inversion require CSI at a transmitter. So B part is the correct option. Question number Question number 4 is the theoretical question, and question is, which of the following power allocation schemes needs CSIT? Try to solve this question. You can comment or speak. Question is, which of the following power allocation schemes needs CSIT? Now option is water filling, channel inversion, capacity with outage, and D is the both A and B. You guys can comment or speak. Okay, so right answer of this question is the D part. Okay, basically the explanation of the question is given. Both water filling and channel inversion use the CSIT to decide the power allocation. Capacity, while capacity with an outage is the scenario where we can only have a CSIR but not CSIT. So water filling and channel inversion is right. This is used for the CSIR condition. So right option will be D part. Next question is the okay. The question is, consider a single tap channel 20 kHz bandwidth with the following SNR characteristic. Find the ergodic capacity of the channel. Question is very simple. Just use the formula of the ergodic capacity and put its values. Here you guys have to calculate ergodic capacity of the channel. Again, I am repeating. Question is, consider a single tap channel of 20 kHz bandwidth with the following SNR characteristics. Find the ergodic capacity of the channel. Please try this. Okay, basically to calculate the ergodic capacity we just use these formulas. Okay, we have the P probability of P gamma, this term is given, and we have the SNRs. Just put the value, and B is our bandwidth. Just put all these values. Okay, and you can calculate. It will become 61.96 kbps. So B part is the right answer. Okay, questions number 6 is also related to the previous one. The question is, find the optimal power allocation for each SNR states of the channel distribution given in the above question. We have to calculate this ratio, and given that three characteristics is given. Please try. Okay, firstly we have to calculate the, okay, we have to calculate the optimal power allocation this ratio. Okay, so for this we use the given conditions. Okay, so maximum the explanation is given there, and that is maximum capacity with CSIT can be used, can be achieved using water filling. Considering all three channels to be in use, the power constraint equation becomes basically for to we have to calculate the firstly calculate gamma naught. Okay, and to using the given values, and the summation of all these terms will be equal to 1. Okay, so gamma 1 is given at 0.115 and the probability is given at 0.20. Similarly, gamma 2 is given the 1 by given gamma 2 is 9 and probability is 0.40. Similarly, we with the gamma 3, and by putting these all values we will get the we will get gamma naught and it will come 0.417. Okay, now we will compare it. The value of gamma naught is contradicting the uses of all three channels, as gamma 1 is the less than the gamma naught, because we are getting gamma naught is the 0.417, but our gamma 1 is the 0.15. Okay, so according to this condition we will not consider the gamma 1. Okay, then we will recalculate the gamma naught. Okay, by using the second and third condition. Again we will put the values of the gamma 2 and gamma 3, and this is the probability of the gamma 2 and this is the gamma 3, and from there you will get gamma naught is the 0.75. Okay, and our gamma 2 and gamma 3 is greater than the gamma naught. Okay, so we will we will we will select these two values. Okay, so from there we can calculate the our power allocations, and but we just put the value of the gamma naught and gamma I go from the 2 to 3. So, and for the gamma 1 it will become 0. So for gamma 1 it comes 0, and for the gamma 2 and gamma 3 it will become 1.218 and 1.28. Okay, so according to our option, A part is the right answer. Next question also is correlated to the previous one. By using this, here we will calculate based on the optimal power allocation of the above question. Find the maximum capacity. Now we allocate the power, so here we will calculate the maximum capacity. Please try this. In this question, we have to calculate the maximum capacity. Using the as we discussed in the last question. Okay, by using this power allocation coefficient. Okay, you have to calculate a maximum capacity. So please try this. To calculate the maximum capacity, we will consider the gamma 2 and gamma 3. We will not consider the gamma 1. If anyone got the answer, can comment or speak. Okay. Here we have to calculate the maximum capacity. Actually, in the last questions, we already calculated the power allocation coefficient. Here we will just put the values in this formula. Okay. So as I told you that for the gamma 1 it will 0, so we will not consider this. For the gamma 2 and gamma 3 we will so this value is already given. We can already calculated gamma 2 and gamma 3 is the 1.218 and 1.28, and gamma naught is the 0.75. Just put these values, and from there you will get the our capacity is 65.98 kbps. So B part is the right option. Next question is what are the features of having multiple transmitter and receiver in a wireless system? There we have the few techniques as given. You have to tell what are the features of the having multiple transmitter and receiver in the wireless system. Again, I'm repeating. What are the advantages we will get when we are using the multiple transmitter and receiver in the wireless system? We have four options: diversity benefit, capacity increase, spatial multiplexing, and all of the above. You can comment your answer. Okay, so answer will be the all of the above, because when we are using the multiple transmitter and multiple receiver in the wireless system, we are getting the diversity benefit, and somehow will increase our capacity, spatial multiplexing. So answer will be D part. Okay. So this is explanation. Having multiple transmitter and multiple receiver gives both diversity benefits and leads to an increase in capacity. So spatial multiplexing we can support more users. So answer will be D part. Next question is a statement type, and question is which of the following statements are true? The water filling strategy is more power efficient than the channel inversion. Statement 2 is the water filling is suited to channels that experience fast feeding. Please try it. So again I'm repeating. Question is which of the following statements are true? The first option is the water filling strategy is more power efficient than the channel inversion. Next, the water filling is suited to channels that experience fast feeding. Okay. So answer is the D part. An explanation of this question is water filling maximize the throughput only on the good channels. This means the data is delayed when waiting for the fading effects to disappear. And since it allocate power to good channels only, it saves power. So all two statements is the true. So option will be the D part. Next question is question number 10. Question is you have to allocate power efficiency for a fast fading frequency selected channel to maximize throughput over a long period of time. All the while you are heavily constrained by the power. Which of the following will you choose? Question: you have to allocate power efficiency for a fast fading frequency selective channel to maximize throughput over a long period of time. All the while you are heavily constrained by power. Which of the following will you choose? Channel is given fast fading frequency selective channel. We have to maximize the throughput for a long period of time. And given is that all the while you are heavily constrained by power. So which of the following you will choose? If anyone got the answer, can comment or speak. Okay, so for the question number 10, answer will be C part. C mean both A and B. Okay, so the explanation of this, the channel is basic. According to the question, channel is the fast feeding, hence instantaneous SNR changes very rapidly. Next, the water filling over time is required. Channel is, or and given is that channel is the frequency selective. Okay, because every frequency is attenuated differently. A water filling solution is required to select the better channels at any point of time over which data to be transmitted. C will be that answer. Next question is okay 11, and question is in the lecture has shown that using DSS increase the bandwidth of the signal. Which what is the consequence of this increase in bandwidth? How this schemes increase the bandwidth? Just you have to tell the intuition behind this scheme. In the lecture, it has shown that using DSS increase the bandwidth of the signal. What is the consequence of this increase in the bandwidth? So the explanation of this question is according to the question, the scenario is basically DSS scheme increase the bandwidth. Since the bandwidth increases, so time resolution becomes smaller. As time resolution becomes smaller, different multipath component can be distinguished, and hence they can be combined in using MRC. This is the intuition of this question. Intuition for this question, and right A part is the right. So right expression is time resolution becomes smaller, as a result many multi-part components can be received which can be combined using MRC diversity combining techniques. Next question is 12, and this is the statement type. Question is based on the statement, choose the correct option from in those two statements. Question is DSS increase the bandwidth of the signal. Next is that DSS doesn't after the magnitude of the frequency response. Sorry, it is not after, it is the effect. DSS doesn't affect the magnitude of the frequency response. It will be a effect. You have to tell if this scheme increases the bandwidth of the signal, and then second is that this scheme affect the magnitude of frequency response. Doesn't affect. It is true or false. And the full form of this scheme is direct sequence spread spectrum. From the last question, you can say that this scheme increase the bandwidth of the signal. So statement 1 is the true, and you just have to tell this statement is true or false. It's affect the magnitude or not. Okay, so explanation of this question is here that sequence spread spectrum increase bandwidth and decrease the magnitude. So the statement 2 is false and statement 1 is true. So option A is the right. Sorry, C part. Statement 1 is true and statement 2 is false. I think A and C is both are right because significance of those options is true. A and C is right. Question number 13 is, in CDMA multiple user can occupy the same frequency band at the same times. It is true or false? In CDMA, multiple user can occupy the same frequency bands at same time. It's true or false? So it is true. This is the CDMA is known as a code division multiple access, and from there we can transmit the signal at the same frequency band at the same time. So it is true. A part is the right option. Next is the, which of the following are spread spectrum technologies? WCDMA, CDMA 2000, IS-95. It is also an Intrinium standard 95, or all of the above. You have to tell which of the following are the spread spectrum technologies. Okay, basically all three options is right true, and these all is increase the in come in the category of spread spectrum. So WCDMA, CDMA 2000 are IS-95. The option will be D part. This is the right option. Next question is spread spectrum communication use chip for the transmission and reception of the signals. You have a modulator with a chip duration of the 1 microsecond. You are transmitting a signal with a symbol rate of the 62.5 kbaud. What is the splitting factor? So this question you have to calculate the splitting factor. Please try this. Again, I am repeating this question. Question: spread spectrum communication use chips for the transmission and reception of signals. You have a modulator with a chip duration of the 1 microsecond. You are transmitting a signal with a symbol rate of the 62.5 kbaud. So what is the splitting factor? The options are 16, 32, 125, none of them. I'm giving you a hint. You can just calculate a symbol duration, and you have the chip duration. By dividing that chip duration with the symbol duration, you can calculate the splitting factor. So from the using the symbol rate, you can calculate the symbol duration. Please try this, or let me know which is the right. To solve this question, first calculate the symbol duration using the symbol rate, that is given 62.5 kilowatt. Okay, in this question, given chip duration is given 1 microsecond and symbol rate is given 62.5 kbaud. Okay, so from using this we will calculate the symbol duration. So this is the symbol rate 62.5 kbaud. You can write in the symbol per second. It will become 62.500. So our symbol duration will be, from there you can calculate the symbol duration. So it will come 16 microsecond. Okay, and chip duration is given according to the question is 1 microsecond. Symbol duration will come 16 microsecond, and chip duration is 1 microsecond. From there you will get your splitting factor. It will become 16. So 8 part is the right answer. So it can spread your bandwidth at 16 times. Yeah. Question number 16 is, consider two users simultaneously transmitting a single receiver in the EWGN channel. Okay, this is a typical scenario in a cellular system with multiple users sending signal to a base station. Assume that users have received power of 10 milliwatts and 14 milliwatts respectively. The channel bandwidth of each user is 20 megahertz. Suppose that receiver decode user 1 signal first. In the decoding, user 2 signal acts as a noise. Assume it has the same static set as EWGN. What is the capacity of user 1 channel with the additional interference noise? Basically, in this question, we have to calculate the capacity of user 1. Okay, so please try this. Again, I am explaining this whole scenario. Question is, considering two users simultaneously transmitting to a single receiver in the EWGN channel. Okay, this is a typical scenario in cellular system with multiple users sending signal to a base station. Okay, there are multiple users sending signal to a base station. Assumes the user have received power of 10 milliwatt and 14 milliwatt respectively. The bandwidth of each user is 20 megahertz. Suppose that receiver decode user 1 signal first. In this decoding, user 2 signal acts as a noise. What is the capacity of user 1's channel with the additional interference noise? Okay, so this is the explanation. The user 1's transmitted power is given. Actually, assume the user have received power of 10 milliwatt and 14 milliwatt. Okay, so signal power is 10 milliwatt. Interference is the 14 milliwatt of user 1. And noise is given as 0.1 milliwatt. So from there, by using this data, we can calculate the SINR. So it will become 0.709. When you will get your SINR, you can calculate your capacity. So it will be B log to 1 plus SINR. Just put these values, and from there you will get 15.47 Mbps capacity. So see what is the right. So thank you, and this is the last question for the session. Thank you.